All right, so for number 2 on bell work, they have given us the equations y plus 5x equals 4 and y equals 7x minus 20. All right? So we already have one that's completely by itself. That's the one you want to start with. If they didn't have a variable completely by itself, then you would want to get a variable completely by itself and then start at this point, all right? But they gave us one. And so we're going to use the one that's all by itself, and whatever that equals, we're going to plug in for that variable. If y equals 7x minus 20, then we are going to plug y equals the 7x minus 20 into the y for the other equation. So we're going to rewrite this equation and replace the y with what the y equals from the other equation. So we're going to take y plus 5x, and instead of y, we are going to write 7x minus 20. Y plus 5x equals 4. And that's from that equation, y plus 5x equals 4. We just replaced the y, substitution. We substituted, all right? We don't need to distribute anything to get rid of those parentheses because technically there's a 1 in front of it. And so if we distribute a 1 to get rid of the parentheses, it's not going to change anything. So our equation looks like this, 7x minus 20 plus 5x equals 4. And I wrote 15. All right, we're going to combine our like terms. What are our like terms here? Right, so my 7x and my 5x give me a 12x minus 20 equals 4. I want to get that 12x completely by itself, so I'm going to add 20. So I have 12x equals 24. My final step to solve for x is divide by 12. So x here equals 2. Once I have x, I need to take that x in and plug it into the equation to solve for my x. So to do that, I'm going to say I'm solving for y. So 7 times what I know my x is minus 20. 14 minus 20, negative 6. So my final answer here is 2, negative 6. That is solving by substitution. All right, so page 350, number 5. They have both of these by themselves, right? Y equals 4x minus 8 and y equals 2x plus 10. All right. If you have both of them by itself, then you can really just set them equal to each other. So I have y equal to this. I can replace y in the other equation with that. So I'm going to have 4x minus 8 equals 2x plus 10. And I'm just going to solve for x like I would, minus 2x. All right, I get 2x minus 8 equals 10. I'm going to add 10 to both sides. Add 8 to both sides, right? So I get 2x equals 18. And then I am going to divide by 2 to get my x. Once I have my x, plug it into either equation. It doesn't matter which one. It should work for both because we're solving for that. So if I just plug it in, y equals 2 times 9 plus 10, 18 plus 10, y equals 28. So my answer here would be 928. The reason it works is because you're trying to solve where they both have the same x and y. So I took the second one here, but if I took the first one, y equals 4 times 9 minus 8, 36 minus 8 is also 28. You will get the same answer, no matter which one you choose to plug it back into. So page 353 in your books. Elimination method. It is sometimes called the addition method, and you'll see why. You're actually adding these equations. All right. So we've solved by graphing. We've solved by substitution. This is actually solving by elimination. This happens to be my favorite way to solve these. I prefer doing it this way than any of them. The point of elimination is that you eliminate one of your variables. All right. You eliminate one of your variables by adding the two equations. So before you even start this method, you have to first make sure that one of your variables will eliminate when you add them, all right? So if I look at these equations that they have given me, 5 plus 3 does not eliminate. But if I look at the y's, I have negative 6 and positive 6. those will eliminate. And so I can go ahead straight to the addition process to do this elimination. And so this is what we do. We take those equations, 5x minus 6y equals negative 32, and 3x plus 6y equals 48, and we add them. All right, we are going to add them. Just add straight down. Line up your variables, add it straight down. 5x and 3x give us what? 8x, right? Negative 6y and positive 6y cancel, right? And then negative 32 and positive 48 give us what? 16. And then I am going to solve for my x. Divide by 8. So x is going to equal 2. Remember, for these, you have to have an xy. So I am going to pick one of my equations. It does not matter which one, and I am going to plug that x in. All right, so if I plug that x in, I'll say 5 times x minus 6y equals negative 32. 10 minus 6y, negative 32. Subtract 10. 6y equals negative 42. Divide both sides by negative 6. Y equals 7. So my final answer here is 2, 7. You can always check these. Plug in your xy to both equations and make sure you get a true statement. And that is how you check these, all right? So elimination, the first thing you want to do is say, will a variable eliminate if I add them? If it does, add them, solve, plug it back in to solve for the other one. So go ahead and try one. Bottom of page 353, check understanding number 1. Set it up for you. If you were to add this straight down, your x's will cancel, right? We have a negative 6 and a positive 6. So if I add, 6 and negative 6 cancel. Negative 3 and positive 5 give me 2y. 3 plus 3 give me 6. Divide both sides by 2. I get y equals 3. Pick either equation, the top one. 6x minus 3, I'm going to plug it in for y, equals 3. So 6x minus 9 equals 3. Add your 9 over. Divide by your 6. So your answer here should have been 2, 3. Word problem. Suppose your community center sells a total of 292 tickets for a basketball game. An adult ticket is $3. A student ticket is $1. The sponsors collect $470 in ticket sales. Write and solve a system to find the number of each type of ticket sold. Each type of ticket sold. All right, so you can use X and Y. They use adult for A and S for student. It doesn't matter. So if X is my adult ticket and Y is my student ticket. All right, X is my adult ticket, Y is my student ticket. All right, total number of tickets sold. That is my X numbers of tickets plus my Y number of tickets will equal the total number of tickets. Yes. All right, dollar amount. Adult tickets cost $3. All right, so $3 times how many adult tickets I sold will be that dollar amount. $1 times my Y tickets sold will be that amount. And the total sold is $470 worth. All right, you'll notice nothing will cancel. This is a problem, right? If I add down, is anything going to cancel? No. Now I do have a 1y and a 1y, correct? So I am going to multiply the top equation, every single piece of it, by -1. All right? So I'm going to multiply this by -1, this by -1, and this by -1. Which is fine, as long as I do the same side from one side of the equation to the other. I haven't changed it, correct? Now will something cancel? Yes, my y's will cancel. Now I can go to the step of adding down. So now I can add down -1 and +3. That is 2x. My y's will now cancel. All right. -292 and +470 will give me what? +178, right? All right. And then my final step here is to divide by 2. Divide by 2, right? 178 divided by 2 gives me x equals 89. How many adult tickets did I sell? 89 adult tickets, right? To solve for my student tickets, I just say 89 plus my student tickets equals 292, right? And then I solve that. Subtract my 89, subtract my 89. My student tickets sold were 203. All right? 203 student tickets sold. All right? So if it won't cancel, but you have the same coefficient, you can just multiply one of the equations by -1. -1, and then it will work. All right? Then it will work. So if you set up your X and Y, X for student, Y for adult, or vice versa, however you did it is fine. When you add them, that equals 64. The students cost $1, the adults cost $2.50. You do have to negate this one and add down. Your X's will cancel. -1 and positive $2.50 is $1.50. -64 and 109 is 45. Divide both sides by 1.5. 45 divided by 1.5 is 30. Or if you did it with fractions, which I prefer actually, keep, change, flip, and you can see that it equals 30. So 30 adult tickets. Plug it back into your original. Student tickets plus your 30 adult tickets equals 64 altogether, so they were 34 student tickets. Example 3. I have 2x and 10x. Those will not eliminate. I have 5y and 3y. Those will not eliminate. Nor will any of them eliminate if I just negate it. All right? So just like I multiplied those by -1, I can actually multiply an equation by anything as long as I multiply both sides of the equation by it. All right? And so my goal is to look at my x's and to look at my y's and say which one would be the easiest to get to be the same, just one positive and one negative where they will eliminate. For 2 and x, all I would have to do is multiply the 2 by -5. And then I would have -10 and positive 10, right? For the 5 and 3, the y's, I would have to multiply the 5 by 3 and 3 by -5. I would have to actually multiply both equations here. So when I look at this particular one, I would choose to eliminate my variable x. Now, you may eliminate whatever variable you want, but I choose to eliminate the one that only requires one multiplication here. There are times when you must multiply both because that's what it gives you. It gives you the only option is to have to multiply both. But when I look at these, I'm going to say which one's the easiest. The easiest one here to eliminate is going to be my x. And the way I'm going to eliminate it is I am going to multiply this top equation, the entire thing, by -5. All right? So I'm going to say -5 times 2x plus -5 times 5y equals -5 times -22. I'm going to multiply every piece of it by the -5. So now that equation, it's the same equation, because remember, just like balancing, whatever I did to one side, I did to the other, it's still the same equation. It's going to look like this, -10x minus 25y equals a positive 110. Okay, positive 110. All right, now that I've done that, I am not going to touch my second equation. I am going to bring it down exactly the way it is. 10x plus 3y equals 22. All right. Now, will a variable eliminate? Yes, my x's will now eliminate. So now I'm ready to add it down. -10 and positive 10 cancel. -25 and positive 3 give me what? -22. 110 plus 22 gives me what? 132. And then my final step here is to divide by 22, -22. So -22 actually goes into this. If you don't know it, you can actually do 11 goes into both of those, 12 over 2, and then it's going to be 6. So if you don't know that it automatically goes into it, you can reduce that until you see. You could reduce by 2, and reduce by 2 again until you finally see that it does reduce to 6. But positive 32 divided by -22, it gives you a y equals -6. Now that I know my y, I'm going to go back to my original equations. Because what did I do is I created bigger numbers. So I want to go back to one of my original equations, either one of my original equations here, to solve for my x. So 2x plus 5, and instead of y, I'm going to write -6. Equals -22. So 2x minus 30 equals -22. Add my 30. 2x equals 8. Divide by 2. X equals 4. All right. It would be 4 -6. You would catch that when you plugged it back in, right? 4 -6. All right. So when I look at these two, -2x and 7x, I would have to multiply both of those, which we're about to do one that you have to. But 15 and 5, all I have to do is multiply the second equation. is a positive 15 and a negative 5. So I only have to multiply the second equation by a 3. So I'm going to leave the first equation alone. Negative 2x plus 15y equals negative 32. I'm going to multiply my second equation by 3. So I get 21x minus 15 equals 51. And now I'm ready to add them. Negative 2 and positive 21 is positive 19. Positive 15, negative 15 cancel. Negative 32 and positive 51 give me 19. So when I divide, my x equals 1. Go back to my original equations and plug in a 1 for x. Negative 2 times 1 plus 15y equals 32. So then negative 2 and 1 give me negative 2. Plus 15y equals negative 32. Add my 2 to both sides. 15y equals negative 30. Divide both sides by 15. Y equals negative 2. And that would be my answer. 1, negative 2. Questions on that one? So flip to page 356, example 5, multiplying both equations. For this one, 4x and 7x do not cancel. Positive 2 and negative 3 do not cancel. So I'm going to look for the easiest one to multiply. My least common multiple between 4 and 7 is 28. So I will have to multiply the top one by 7 and the bottom one by negative 4, or vice versa. The 2 and the 3 is already positive, negative, and it's smaller numbers. So if I were choosing to eliminate one, I would eliminate y. You may choose whichever variable you want to eliminate, all right? But in this case, I would actually multiply the top equation by 3. That would give me a positive 6y. And I would multiply the bottom equation by 2. That would give me a negative 6y. And that would allow for my two equations to have an elimination of one of my variables. All right? And so that's what we're going to do. We're going to say 3 times 4x, 12x, 3 times 2y, 6y, 3 times 14 is 42. Then we're going to do the bottom one. 2 times 7x is 14x. 2 times negative 3y, negative 6y. And 2 times negative 8 is negative 16. Now I have a variable that will eliminate when I add them. And so I'm going to take this and I am going to add down. 12 and 14 give me 26x. Positive 6 and negative 6y cancel. 42 and negative 16 give me 26. And then to solve, I am going to divide both sides by 26. And my x is going to equal 1. Now, I made both of these equations larger numbers. I am going to always go back to my original equation, all right? Original equation here. And I'm going to take that 1 and I'm going to plug it into one of my original equations for x. So 4 times 1, 4x, plus 2y equals 14. 4 plus 2y equals 14. Subtract my 4 from both sides. 2y equals 10. Divide both sides by 2. Y equals 5. So my answer for this one is going to be 1, 5. And again, you can check by plugging 1, 5 into both of your original equations. All right, so go ahead and try one. Check understanding number 5, middle of page 356. So check your work. If you decided to cancel your x's, you need to multiply 1 by 2 and 1 by negative 3, or 1 by negative 2 and 1 by positive 3. You need to end up with a positive 30x and a negative 30x here. When you add, your 30x's will cancel. 6y and negative 21y gave me negative 15y, and 18 and 12 gave me 30. Dividing gave me y equals negative 2. When I plugged it back in, I got x equals 1, 1 negative 2. If you decided to cancel your y's, top one by 7, bottom one by negative 3, or this could be negative positive. Either way, your y's will cancel. 105x and negative 30x is 75x. When you add these two, 75 and x is 1. When you plug it back in, y is negative 2. Either way, you get a final answer of 1, negative 2. Give this to you towards the bottom of 356. Can I eliminate a variable just by adding or subtracting? Yes, then do it. Add them and get your variable. Or by subtracting, that means just change one of them to all negatives, right? Can I multiply an equation, just one of them, and then add? Then do it. If not, you will have to multiply both equations to get a common one to eliminate.